Greetings, Artie from Artifact Electronics here. In today's episode, we'll be having a look at this Xbox 360. I bought this as non-functional, and it came with a little note that was taped to the side here. And the note says, slowly gets louder and louder, fan bearing load. Signed AR. But back to the Xbox in general. This is of course a first generation 360, which is also unofficially called the Fat 360, and that's because they came out with a second generation that was somewhat smaller than this, and that one was called the Slim 360. So here we have a Fat 360. On top of that, this is the special Halo 3 edition that comes in military green with some extra graphics on the side and the gold cover on the DVD drive. And yeah, I think it looks better than the original off-white ones. Well, it looks more interesting than those. The case is in pretty good shape. All the little flaps here for the memory cards and the USB connectors are there with the springs installed in them. And but of course it came devoid of any accessories. We'll talk about the price a little later on, but this was it. No cables, and it didn't even come with the hard drive, which was kind of sad because the hard drive, I think it has the gold trim on it, so it matches this, but I'll just have to go out and look and see if I can find one of those. But of course, first let's see if we can fix this guy, and if he gets fixed, I guess then we'll get him a new hard drive. So let's hook him up and see what he has to say. Alright, it's hooked up to power and to my trusty high-res bench monitor over there. So let's see what this loud fan business is all about. Fan sounds normal. There's cold air coming out of it. Power splice is green. You might not be able to hear this exactly, but the fan's beginning to spool up already. I mean, it's nothing horrible or anything like that, but generally the fan doesn't start speeding up like this early after power is applied. And yeah, it is just continually increasing in speed. And that's definitely not bearing noise. That's just the fan, or I should say the fans, getting faster all the time. Air is still pretty cold coming out of it, so let's give it a little bit of time. And now it is getting a bit loud. And the air is beginning to warm up, which is to be expected. I mean, at this point the GPU is probably pumping out a good amount of heat. So yeah, it just keeps doing that. So to take a logical approach to this, it's heating up very quickly, which is indicated by the fan speed, which is variable and CPU controlled. And the CPU is probably seeing something in there, some of the thermocouples reporting continuously increasing temperatures, and it's trying to make up for it. Now this is pretty loud. I mean, normally Xboxes don't get this loud. Air isn't really hot. I mean, I guess the fan is doing its job, but this behavior is not normal. So we're going to have a look inside logically what is happening here, what I'm guessing it is it's either really dirty inside, or the heat sinks are all full of dust, or what is even more likely, they use thermal pads on the heat sinks instead of actual thermal paste, and those pads actually disintegrated after a while. So that could be another problem, that the ICs aren't making proper contact with the heat sinks, and so everything's warming up very quickly. But in order to find that out, we'll have to open her up. Alright, we're ready to open them up. Now I'm not going to show you in excruciating detail how to get to the main PCB cage in here. And that's because a few episodes back I did an episode on another Xbox 360 which had a hard time with a stuck DVD tray, and we fixed that, and that's episode number 33. So if you're interested in the exact details of how to get the plastic shell off, please watch that one before continuing to watch this one. However, what I am going to do is remove the front panel first. And the reason I'm doing that is I want to see if any consumer has messed around with this yet, and that we can determine by seeing if the warranty sticker inside is still intact. Boy, the other one came off easier. But here we go, and you can immediately see that there is an intact warranty sticker right over here, which I will proceed to rip off, but at least it looks like nobody outside of Microsoft attempted to go in here and muck around with it. So let me repeat what I did in episode 33, and then we'll continue. Okay, we got it all open. I think you can see pretty clearly that, yeah, there's some dust in there, but there's not nearly enough dust in here to cause the behavior we observed. So my guess is still that there is something wrong with the heatsink paste underneath these two guys. So let's go ahead and do what we didn't do in episode 33, and that is remove the main PCB. So first we'll take out the fan shroud here. We see a piece of plastic fall off. It's interesting, it came from here. Well, that's not going to cause it either. Some dust on the fans. Not really a lot of dirt coming off here, so anyway, we will remove the shroud. Then we got to remove the little front panel PCB. That has a power switch on it, and it has a small MCU over here. I think that's the one that monitors the temperature and does reports what's happening, and if the temperature goes too high or things go really wrong, actually shuts down the whole system. In order to get this out, we got 3 screws securing the little PCB to the front. And this is simply plugged in. So once the screws securing it are out, it'll just unplug. And there you have it. Oh, there's another processor on the back, or whatever that is. Okay. The drive, of course, is out. As a point of interest, please note that drives on 360s are not easily interchangeable. So if you have a 360 with a bad drive, You can't just buy a real cheap one with a ratty cage that has a working drive, take it out of that one, put it in here, and expect it to work. They are locked to a password contained on the motherboard here, and in order to use another drive, you actually have to reflash it with the password of your current PCB, your current motherboard. And of course that means you have to find a way to retrieve the current password from the current motherboard, and it is not totally trivial. I'm sure that it is well documented on how to do it, but doesn't sound like a real pleasant task to me. Anyway, so to further continue, we will turn it upside down and remove a whole bunch of screws. There are 8 T8s over here, and there's another 9 T10s around the perimeter. So go ahead and remove those. Okay, and I worked super quick as usual. And all the screws are out. Turn it back around. I should be able to lift out the motherboard now. Don't forget to disconnect the fan connector, power connector, and there it is. See some thermal pads that are stuck to the case. So yeah, I guess they definitely use thermal pads in here. A wayward inspection sticker, I would say. 1041 looked at this or inspected it. But now we got to get the heat sinks out of here. And the heat sinks are held in place by these X-shaped clamps. And we have to remove them, but you got to be kind of careful, because I've seen a couple of boards. I mean, if you look closely, you can see there's fine traces, like around this connection point here, running around it. And I've seen some boards where people have just indiscriminately stuck screwdrivers in here to pry off these, and in the process cut through the traces and rendered the board useless, because trace repair on a board like this is probably impossible, except for the most patient ones, and I'm not one of those. So if I had a board like that, it would be trashed right off the bat. But so let's see what we can do here to get these guys off. And the way I do it is I stick a screwdriver between the post and the edge of the clamp and just gently pry it up till it releases. You continue doing that in a round-robin fashion. Ow. Yeah, be careful, there's some sharp edges in here. And if you do it carefully enough, you will not damage anything. And really the hardest part is getting the first 2 off, because then tension is released on the remaining ones and it pretty much just comes off. And that leaves the last one, but I'll just do that quickly off camera and we'll have a look at the heat sinks. Alright, the clamps are off, and when I turned it around I immediately noticed that these heat sinks immediately came loose. And that's not something that should be, because you usually have some paste under there, thermal transfer paste, and it naturally hardens over time. And what it does is it has an adhesive effect and keeps these things in place even if they're unclamped. And if they're coming out this easy, something's not right in here. Because on others, what I have seen is when I removed the clamps and I tried to pull these off, they wouldn't budge. I could not get them off, even pulling on them really strongly. And what I had to do was power up the board, let it cook for a while, and that would soften the paste enough to a point where I could just pull the heat sinks off, but not here. So not a whole lot of paste left there. And not a whole lot of paste left there either. And almost no paste left on the actual chips. So let's go ahead. We're going to have to use some acetone and elbow grease to clean off the old paste, apply some new paste, and then put it all back together again and see if we've made any difference. I'm going to use Q-tips and acetone, and that's because once this paste mutates into whatever it becomes now, probably a potent adhesive, alcohol doesn't do anything with it. Alcohol can't fight it, but see, the acetone is pretty effective here. The chips are actually the easy part. Cleaning up the underside of the heat sinks gets a little bit more difficult. But you just want to go in and clean off any trace of the paste, the leftover paste, from the top of the chip. Don't worry too much about the overflow. As you can see, you know, there is a bunch of stuff surrounding the chip. Those white outlines are actually overflow, or of the glue, I shall call it, what it is now, because that paste is not thermal conductive, is not electrically conductive, and thus doesn't pose a problem. And now we have to do the same thing for the heat sinks, and that's going to take a little longer, so I'll get right to it. Ah, the smell of fresh acetone. So we got it all cleaned up. As I mentioned, the heat sinks themselves are a little bit more difficult to get the old paste off, but this one got clean, and this one got clean, and of course we have the chips, which are all gone, all cleaned up, and there is some overflow on the sides, as I mentioned before, but I'm not going to bother with that. So the next question is heat transfer paste, what type to use. And one thing that's very popular nowadays, people who overclock their CPUs use something called Arctic silver, which is paste with laced with actual silver particles. And to me personally, that's good and bad. The good is that the silver conducts heat extremely well, much better than the paste itself, and should thus work better than just regular paste. But silver also conducts electricity, and the idea of having conductive paste, have a look at the GPU carrier over here. Sure, the unit itself is BGA. It's a ball grid array with the little tiny balls underneath it that are soldered to the board. So if you put some conductive paste on here, even if it overflows, it's not going to harm you. But the carrier has a bunch of ICs, surface mount ICs on it, and we can see over here that the old overflow is actually overlapping. Well, it's getting really close to overlapping some of the pins on these ICs. If that paste were to be conductive, to me that would spell lots of problems. So what I do is I just stay with the standard heat paste, non-silver laced, the stuff you can buy at local electronic supplies or off of eBay. And from what I've read, and this is secondhand information, is that when you initially apply the paste, whether it's silver containing paste or plain paste, the heat transfer characteristics are almost identical in the very beginning. However, then as time passes on, the plain stuff dries out a little bit quicker and the heat transfer characteristics become worse, whereas the stuff laced with silver supposedly stays soft for a longer time and is thus a better long-term solution. But for the reasons stated before, I'm just going to use plain paste. It's stuff like that comes in a which looks like a mayonnaise packet you get out of your local diner. And the last point of interest is that if you could theoretically use toothpaste, and initially it will work just as well as the other stuff, the difference being that after about 12 hours of on time, or even just sitting in, coming in contact with air, the toothpaste would dry out and essentially completely nullify heat transfer characteristics, whereas the difference between that and real heat transfer paste is that it has additives that keep it soft for a longer time and thus maintain its properties. Alright then, time to lather up. So just going to start applying paste. It's a good amount of paste. But in my experience, better use too much than not enough. I mean, the rest of the stuff, once you put the heatsink on, is going to get squeezed out. But the more of this you put on there, the better a chance you have of all the nooks and crannies being filled with the paste when you finally put on the heat sinks. The only thing to do is distribute it a little bit. Don't try to make an even surface. Just make sure that there's paste on every part of the chip, that you can't see any part of the chip bare, and the rest will be taken care by the heatsink. And it may look like I'm using a lot, and I am using a lot, but in my experience it's better to do it this way than to economize on the heat paste and possibly create areas that are free from the paste once the heatsink is placed back on. So there you have it. So reinstalling the heatsinks is not too big of a deal. Let's put the CPU one back on. Turn it around and reinsert the clamp. And of course, insert the clamp. Inserting it upside down isn't going to work really well, so. And now the same for the GPU. And make sure to support the GPU with your hand, because it's not as tall as the CPU one and it'll just fall out. Then give each arm an extra push to make sure that it's latched in. And that completes reinstallation of the heatsinks. So to test this, I just put in the PCB back into the shell, hooked it up to the fans, put the control panel up front. Here's the shroud. If you remember, there was a chip broken out over here. I don't know how that happened, if PCBs could speak, but I just super glued that back in place. and reinsert the shroud, hook up video, power, and controller, and off we go. The fan is nice and quiet. It's not spooling up. So I'm going to let it sit for a few minutes. Because when we tested it before, the fan was already spooling up at this point. But it's pretty much acting like other Xboxes that are in good repair. And you can kind of hear it whirring in the background, but it is not accelerating or anything. So maybe it's a good time to put the drive back in and fasten some screws in front and actually load a game, because once a game runs, the GPU load becomes much higher than it is now, and that would probably be a truer test of if our application of new heatsink paste worked or not. Alright, we got the drive in now. Let's start her up again. And one thing I've also done is, just like I showed in episode 33, I actually took the drive. I haven't tested the drive, but I took it, opened it up, blew out the dust, cleaned out the tray rails, and I also replaced the belt, the tray belt. And the other one didn't look too bad, but if the tray belt starts wearing or stretching, it will cause some really weird drive behavior, and that's because it can't pull the door or the tray closed all the way if it's slipping, and the limit switches will show some odd behavior. So I would recommend that you go out, if you're going to work on a 360, get yourself a few belt replacements for the tray and have them handy, so whenever you work on one of these and you're cleaning things up, replace the belt as preventative maintenance. So while I was talking, you can see the fans running normal, and now it's time to go ahead and test the drive, put a game in, and what game is more apt than Halo 3? Well, it's making a racket, so and it loaded. Of course, with the racket the drive makes, we can't really hear what the fans are doing, but looks like the fans are pretty much still running at a low speed and emitting hot air, which means that the heatsinks are doing their job. So again, let me thank you very much. So again, let me have this sit here and run for a while, and then we'll come back and check to see if the fan speed is still normal. And that may be the end of the video, because it looks like we actually fixed this guy. So about a half hour's passed. All I can really hear is the drive spinning, and this guy's been patiently waiting for me to look up. There is very warm air coming out the back, and that's good, of course. One thing, when you have something that's malfunctioning on an Xbox, that's one of the initial tests you should run, and that is turn it on and see if after approximately half a minute there is a really warm air being emitted from the back. If there isn't any warm air coming out, that is a very clear indicator that the heat isn't getting transferred to the heat sinks, because if you turn on an Xbox and you get a display, the CPU and the GPU are running and they get hot very quickly. So if there isn't hot or very warm air coming out the back after about half a minute or so, you definitely have a heat transfer problem in the heat sinks, and you need to apply the procedure to your Xbox that I just did. So I guess we're at the point where we can put it all back together again and finish up the episode. Oh, I should probably stop the game running so the DVD stops spinning and we can hear the fan. So the fan was running a little faster, but it slowed down as soon as I stopped the game. And yeah, looks like it's working. Alright, put it all back together again, and it still seems to be working. Normal fan noise. It's not speeding up or anything. But another thing is, I was pleasantly surprised today because the mailman brought me something nice. And this is what he brought me. A hard disk that matches the Halo edition. So let's put that one in. And then talk about what this whole setup cost me. There you go. The sides match. Cool looking. And let's see if the hard drive works, which is another thing. But while we wait for it to boot up, basically what I'm into this for is I bought this along with some other parts, and doing some simple math, the Xbox shipped to me cost $23. Came off of eBay and it was shipped clear across the country, so that's not a bad deal, especially since I got it to come up and it's working properly. And I found the drive for that was $11 shipped. So my total investment is what, $34. And again, since I got it to work, that makes it okay. If I couldn't get it fixed, then wouldn't be too happy. But I think it was worth it, and I got a special edition Halo 3 for a total of $34. And it didn't come with the joystick, so I'm going to have to go out and get a controller that I think is the same color as this. But other than that, it looks like it's running fine. Let's have a look at the hard drive. I don't even know what size it is. 13.8 gig free, so I'm guessing it's probably a 16 gig drive. And so that's it. Hope you enjoyed it. These Xboxes, like always, they're not necessarily easy to fix, but most of them can be fixed. And it's quite a journey to go through them, especially removing the case. So that's goodbye, I guess. Leave me a thumbs up if you liked it, and make sure to subscribe. And we'll see you in our next adventure.